Yeah, I'm working on a talk I'm giving tomorrow at a meetup called Next Scene. Let's go to the studio. Boom! Unsupported, whatever. I don't know what that is. Let's just turn that back on. BPMN, why would you even? The value of processes as first-class entities. And what I'm up to today is this kind of the last, putting it all together. On my 2G connection. Hopefully that will be okay for networks. BPMN, why would you even? So I'm just going to kind of walk through this thing, assemble it, and kind of talk my way through it. And it's going to serve as compilation and rehearsal. Been crystallizing these ideas over the last couple of weeks, and it's time to bring them all together into one amazing presentation. Okay. We close that because it's company confidential. Goodbye. Okay, so BPMN, why would you even? Next slide, introduction. Here we go. No force on earth can stop an idea whose time has come. Let's get rid of these extra things. Hello, what's up with the CPU? Kernel task, very high. Frequency scaled down. So Ecamm Live chews up a lot of CPU. Let's see if there's an update available. Check for updates. Checking for updates. Oh, there's a new version. I'm going to install it. I'm going to try again. Okay, cool. But while I'm doing that, I'm going to delete these things. Delete. Delete. Escape delete. Click on this thing here. Send it to the back. Victor Hugo. I don't even really know who this guy is, but I mean, this quote I've known forever. Order. No. Send to the back. Delete. Delete. No force on earth can stop an idea whose time has come. Historical inevitability. So my thesis for my talk is that BPMN is an idea whose time has come. BPMN is business process model and notation. It's a computationally amenable format for describing processes. And I got like a little kind of demo BPMN process here. And what I mean by that it's an idea whose time has come is that it is a solution that is a good fit for the class of problems that we face today as software developers and organizations that produce software. So that's the thesis of my talk. And to begin with, the other thing is that in this talk I'm going to share my love of computing because I'm a massive nerd and I love computers. We're going to begin with like a brief history of computing, which sets the context to build the case. Here's my next quote. It's from Napoleon Bonaparte. History is a set of lies agreed upon. There's another one which is, of course, history is written by the victors. But I think this one here is kind of like all history is a mythology. All history is a lie, a fable, we could say. History as a lie is kind of a little bit charged, but all history is definitely a fable. It looks through a particular lens, and it selects particular events, and then weaves them together into a narrative that brings us into the present with a particular view of the present. And that's what I'm going to be doing with my history of computing at the beginning of this presentation. So order, send to back. And then we're going to delete these things. Okay, my Ecamm Live is still downloading. There we go. Okay, so let's go to the next slide. Okay, where I've also deleted those things. That's cool. Yeah. Okay, so my particular lens that I'm going to be looking through for this little historical brief history of computing I could put a brief history of computing in here. Let's do it on the next slide. Paste. Okay, whatever. A brief history of computing. And is that centered? Close enough. A brief history of time. Corrupting. A brief history of computing. Okay. So just I'm going to drop this back to text color. I think to about here. Yeah. In which case, we'll elevate this to here, like that. Duplicate the slide. Okay, brief history of computing. So it's a history of abstractions, no, a crystallization of concerns. Crystallization of concerns. Yes. So I think, yeah, okay, if we go back up here, we'll underline this. Underline. Okay, so underline it here. Create a categorical difference. Crystallization of concerns. Duplicate the slide. And the evolution of abstractions. Here we go. Cool. I like it. So, let's duplicate this one. Pull it down here. Delete these two. Delete this one. Delete this one. Okay. So the first thing that I want to do is ENIAC this computer. So let's go for ENIAC. ENIAC. Images. Let's have a look. Which one looks good? I guess we'll go for a big one. Something that's big. That's big. And one that kind of shows people programming it. Oh, this one's cool. View the file. Yeah. Copy. So, ENIAC 1946. So, 1946. ENIAC, electronic numerical integrated encounter accumulator. What does it stand for? Electronic numerical integrator and computer. Okay. Completed in 1945. First put to work for practical purposes in December 10, so it's actually 45. EDVAC was 46, I think. It's going to be my next one. So insert a picture, image. Yep. Search the web by URL. Paste the URL of the image. Insert. Yes. Look at that. Woo, cool. Okay. So ENIAC, 1945. So this thing, some things about ENIAC. So ENIAC was really, well, it's kind of like it's popularly known as the first electronic computer. And it's the first electronic general purpose computer. Okay. Yeah. It uses enough electricity to power a small town. To power a small town, or to mine a Bitcoin. Or to mine Bitcoin. A small town or a Bitcoin mining farm. Actually, that's interesting because I think ENIAC uses like 150 or 250 kilowatts. Let's have a look. Components, operation time. I'll just grep on the page for kilowatts. 2 of 2, so the first one is 150 kilowatts of electricity. So how much electricity? Bitcoin mining farm electricity usage consumption. All. Bitcoin mining now consumes as much electricity as Iceland. How much power does it take to create a Bitcoin? Calculating the cost. Okay, let's have a look. Time taken doesn't vary. Computing power does. To understand the network, you need to understand how Bitcoin creation works. Okay, but exahashes per second. Calculate how many sums that are conducted every second. Find out how much electricity energy it takes to do each sum. Oh my goodness. 120 gigawatts per second. Okay, so it says that it consumes 150 kilowatts of electricity, but 150 kilowatts per watt? Per hour? Per second? I guess it consumes 150 kilowatts of electricity per hour, kilowatt hours. So 150 kilowatts seconds per second or hours per hours. $120 gigawatts. $10 minutes to mine 1 Bitcoin. Oh my goodness. 72,000 gigawatts to mine a Bitcoin. 72,000 gigawatts. So 72,000 gigawatts. That's like 2 orders of magnitude above a kilowatt. Okay, so if one 1 Bitcoin. Okay, this will be interesting. 72,000 gigawatts. Start the calculator. Okay. So 72,000 gigawatts. So megawatts, gigawatts. Okay, so that's how much it takes to mine 1 Bitcoin. Okay, so memory plus that, and then do 150 kilowatts. Yeah, divide by memory recall equals, that's a percentage, multiply by 100. That's how much of a Bitcoin you would get. Can I copy it? I'll just hit Control C. Let's see if I can get a Bitcoin. How much is that worth in Bitcoin? CanXE.com do Bitcoin. Yes. Okay. Here's the amount of Bitcoin. And let's see what that's worth as a US dollar, hey? Duh, because I think most of my audience are going to be in the US. Basically 1 cent. And what? So, okay, that's enough power to mine 1 cent of a Bitcoin. Yeah, okay, so that's interesting. Okay, so it used 150 kilowatt of electricity. Which is enough to power a small town. It is, or it was? Lights in Philadelphia dimmed. A small town. Or to mine 0.01 cent, US 1 cent worth of Bitcoin. In 2021. When was this written? 2020. Oh, we'll go to 2021. So in 10 minutes. Okay, which, I mean, uses 150 kilowatts of electricity. Far out. I think my MacBook Pro uses MacBook Pro watts. 22 watts? 48. No. Laptop power consumption. 29.96. 87. Let's have a look at this. MacBook Pro, 13-inch, power adapter only, plugged in and off, plugged in and working, 12 to 40 watts. So it's like 87. Let's call it 87. We'll max it out. So 150, 1, 2, 3,000 divided by 87. Nearly 2,000 MacBooks. Okay, so that's not really a small town. Okay, so let's say 2,000 modern MacBooks. In 10 minutes. That's a crazy amount of Bitcoin, because to get, if I go back to XE and pull out that this here, if I wanted to mine 1 Bitcoin, I would do 1 divided by, paste that number. That's how many 10-minute units I would need to do. Divide it by 10 to get it to 1 minute. Okay, so that's given me minutes. Divide by 60 minutes to get hours. Divide by 24 to get days. 333 days. Take about a year. So MacBook Pros. Seems like a lot of energy, but for scale, it is the energy needed to mine 1 Bitcoin if run continuously for 1 year. I wonder if ENIAC could mine Bitcoin. I very much doubt it. Okay, let's see if someone has asked the question. Someone has to have asked the question. Could ENIAC be a Bitcoin miner? ASIC miners. Bitcoin mining on Russian nuclear supercomputer proves costly. ENIAC. Okay, it's a decentralized privacy coin. 75 years ago. Oh, wow. Feb 15, 46. First made public. That's why I thought it was 46, yeah. 75th birthday. Epic. ENIAC Day. Okay, I just did some back of the envelope calculations. ENIAC ran on 150 kilowatt of electricity. That's enough to roughly power 2,000 MacBook Pros and enough energy to mine US 0.01 cent worth of Bitcoin in 10 minutes using modern hardware. Or see you guys later. See ya. 1 cent worth of Bitcoin in 10 minutes, or 1 Bitcoin in just under a year. I seriously doubt whether ENIAC could do Bitcoin mining. And if it could, the lifetime of the universe is probably too short. Well, it's Turing complete. Okay. It is Turing complete. So maybe technically it could be possible. But the universe might have too short a lifetime. Okay. 1 Bitcoin on modern hardware. Is that right? Is that how much energy it is? 150 kilowatts. Yeah. Okay, basically, you're talking about having 2,000 MacBook Pros running continuously for a year. Equivalent of that. That's interesting because it means that, well, you know, we think of like 150 kilowatts of power, that's like ridiculous. It's massive, and now my computer can run on 87 for a MacBook Pro. Sure, but there are now computers running, you know, like farms. A Bitcoin mining farm is probably the same size as the ENIAC computer. Let's have a look at how big it was. Occupied 167, so 1,800 square feet. Took up 1,800 square feet of space. So it's Bitcoin mining farm. Remember reading a Vice article about it. Let's have a look. A farm with 3 data centers. Power consumption. Here we go. Had most of his Bitcoin after he promoted them at TV. Okay. Yes. Yeah, that's right. Bulgaria. That could have been the one I was reading about. No, it was in Russia or something. Let's have a look. Interesting. Let's compare that with the picture of the ENIAC. ENIAC. Bitcoin mining farm. So some things interesting. Let's see if we can find a Bitcoin mining farm pictures then. Something that looks like ENIAC. This one. Yeah, very interesting. So, let's go back here. Let's duplicate the slide. And then we're going to swap out this image. Image by URL. Let's drop in this Bitcoin one. Insert. Interesting, hey? 2021 Bitcoin mining. Looks very similar. Okay, duplicate the slide again. Which seems like a lot for a computer. But have a look at a modern Bitcoin mining farm. So that's the next slide. Okay, so the Bitcoin mining farm, and then we come back to this ENIAC thing. There's a crucial abstraction missing. Oh yeah, no, that's the other point is if you implemented ENIAC on modern silicon, and by modern I mean the 20 nanometer process of the 80s, of the 80s microprocessors, it wouldn't be visible to the human eye. So there's a crucial abstraction missing in ENIAC. It's Turing complete, but it's not really a modern computer. It's not really a modern computer because there is no first class abstraction called a computer program. Programming the ENIAC is more like patching a Moog synthesizer. Good luck downloading that from the internet. Let's have a look. Was it the Moog? Yeah, it was the Moog. Pretty sure. Yeah. Nice. Good luck downloading that instrument patch. So duplicate this slide and then kind of replace the, my URL. Replace. And then what I should do here, I think, is like this. When did the Moog synthesizer come out? In the 70s? No. 65 to 80. 64. Okay, whatever. Good luck downloading that as a patch. So here we'll go 1945 ENIAC. And then this is 2021 Bitcoin mining. Saving it to a backup. ENIAC is more like an FPGA, a field programmable gate array. It's more like a modern FPGA. It's similar. Yeah. ENIAC, the electronic numerical integrator and calculator. Okay, debuting publicly 75 years ago this month. There we go. Belonging to the 80s? No. Let's stick it in there. Wouldn't be visible to the human eye. There's a crucial abstraction missing in ENIAC. It's Turing complete. It's not really a modern computer because there's no first-class abstraction called a computer program. Programming ENIAC is more like patching a Moog synthesizer. Good luck downloading that or saving that as a patch set. ENIAC is more like a modern FPGA, a field programmable gate array, where you modify the hardware itself to get specific behaviors. So I think the Z3, do I want to mention the Z3? The Z3 is a computer made by Conrad Zuse in the 38. I think it went into production in 41 or 2. But because of the Second World War, it kind of got forgotten about. It beat ENIAC, but let's just stick with this. Okay, so the first one that came out where you could have a stored program was EDVAC. And that came out in 49. EDVAC. Electronic Discrete Variable Automatic Computer. Yeah, images. The EDVAC. Oh, so much better. John von Neumann. Yeah, okay. Add back. View file? Well, it's going to download it. Okay. Whatever. My new version of Ecamm Live is here, so I'm going to restart and use that. I'll be back shortly.